Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. So today we shall learn about the mechanistic proof of acyl nucleophilic substitution. I know you people have many times written this acyl chloride plus triethylamine plus alcohol which produces this molecule. This is nothing but a star. Okay, we say that these acid chlorides are very reactive because the presence of this electronegative chlorine atom along with oxygen. So that's why it's very reactive. That's why alcohol reacts and produces this ester. And by the way, the intermediate in this case we propose this. How? See, this nitrogen lone pair attacks here, it comes back and this Cl leaves and produces this intermediate, and in the next step the oxygen lone pair attacks here and it helps to leave this NET3 plus, because it's a neutral leaving group, so consequently in this way it produces this ester, and along with that it produces this triethyl ammonium chloride. This is actually a salt. Overall if we see that this triethyl ammonium amine act as a base to produce this. Means if you look at this reaction very closely, in this case one molecule of chlorine, means one chlorine atom, or better say chloride anion, leaves here and one proton leaves from this alcohol, and they both combine and produces one molecule of HCl, and these HCl react with this triethylamine and they both produces this triethyl ammonium salt. Means in this way, since salts are precipitated out or separated from the reaction medium, reaction proceeds in the forward direction. Now question, any proof of reaction mechanism? So that's today's point of discussion. So as I told, how this reaction happens by nucleophilic attack on this acid chloride which produces this intermediate. Okay, this triethyl ammonium cation and chloride as a counter anion. Now question, this we understood. Now question is that any proof, and if the best way to prove something is to isolate something. Okay, so to isolate something, and how to isolate this? See, our main matter of concern is that this whether this cation forms or not. So now how to prove this? For that purpose we take metal tetraphenyl borate salt. Okay, why? Because this tetraphenyl borate anion is a bigger in size. Consequently, what happens, they can isolate this salt cationic part efficiently. Let's discuss. So what happens when you add this metal tetraphenyl borate in the organic medium, means along with the reaction, they combine, this tetraphenyl borate combines with this cationic part and they produces this salt. Okay, so what is the advantage and why this is formed? So first of all, what is the advantage? Advantage is that this cation is bigger in size and this anion is also bigger in size. Why? Because the boron atom is attached to 4 phenyl group. We know that phenyl groups are bulky, not based on the number of carbons. Along with that, it's electron cloud. So consequently, it's a bigger anion. So bigger cation, bigger anion. Consequently, they form a stable combination. Second thing, what is the advantage? Since it is formed and since it is stable, so they could be isolated. And another thing, such salt are soluble in organic medium. So first of all, soluble, and second, they could be isolated. So they could easily be detected by FTIR spectroscopy or UV visible spectroscopy or even NMR spectroscopy. So consequently, what happens? It is very easier to prove that this complex is produced. Why? Because if it produces, then this anion exchange, because this step is nothing but, if you say, it is actually a anion exchange reaction. Okay, now this thing we understood, that why tetraphenyl borate. Now question, in this case the other part, this M is sodium or silver. Question, why sodium and silver? Let's come stepwise. First, sodium. So means sodium tetraphenyl borate, our initial, means it's an ionic salt. Now this case, if you look at this thing closely, this sodium plus is smaller in size, whereas this tetraphenyl borate is a bigger size. So consequently, at the initial phase, size mismatch is there, so stability is less. So consequently, when this tetraphenyl borate get a big cation, it prefers to bind with that, point number 1. Second, there are 4 organic moieties surrounding this boron, this phenyl group. So it has an organic loving nature, and this cation which we have produced is also organic. So this organic matching prefers. Third point, in the reaction medium, what actually we are exchanging? We are exchanging this chloride anion with this tetraphenyl borate derivative. But this chloride, when it exchange, then the remaining cation remains in the medium sodium. So what it produces? It produces sodium chloride, and it's an ionic, very stable compound. So it precipitates out from the reaction medium, means it's separated from the equilibrium, means the equilibrium is shifted, or you can say preferred equilibrium goes to the right side, means this combination, this salt formation, organic salt formation. So consequently you can easily separate or isolate, and you can detect. Point number one. Second thing, we have understood in case of sodium, so this size mismatch is the factor, and this sodium chloride precipitation. Now there is additional information. If you look at this potassium tetraphenyl borate, if you look at this salt, I have already discussed student a dedicated lecture on this. So this potassium tetraphenyl borate is insoluble in aqueous solution. So why this is? Because the size of this potassium and tetrafluoroborate quite matches together. That's why they precipitated out. Not only potassium, even ammonium, cesium, rubidium, they also follow the similar way, because of this larger size of cation, larger size of anion, this thing. Now question, what about silver? Because silver, if you look at, it is a 4D transition metal. So 4D D block element, but not so it's a D block element, 4D series. Now question, in this case, why this silver forms complex? Because since potassium prefers this tetraphenyl borate because of its larger size, then silver should match. Then why silver is allowing this tetraphenyl borate to go with this organic cation? This is because another phenomena, that is the chlorophilicity, or better to say halogenificity, except fluorine, means if you look at this silver chloride is very stable. Not only silver chloride, silver bromide, silver iodide follow the same thing. So this is very stable. So this precipitate out because the silver chloro bond is very stronger. Not only some covalent character is also there. So that's why since silver loves chlorine more compared to this tetraphenyl borate anion, so consequently it allows this tetraphenyl borate to go with the cationic species, and it takes this, exchanges this chloride anion, and that is the main driving force for this formation when silver tetraphenyl borate is used as a salt. Now we have understood the mechanism. So if we look at, in summary, what we have learned from here, the anion is bigger in size. So the anion is bigger in size and the cation anion size matching occurs. That's why salt formation occurs, means organic. The size matching of the ion make the organic salt less hygroscopic, because tetraphenyl borate we have used. Instead of that, if you use tetrafluoroborate, same case like sodium tetrafluoroborate, so you may expect that such same type of phenomena observe. You may observe, but remember this tetrafluoroborate is not that much bigger, so consequently some hygroscopic natures are there. So that's why we can't use tetrafluoroborate. Instead of, we use tetraphenyl borate. Now tetraphenyl borate anions are very big and non-nucleophilic, because 4 bulky phenyl groups are surrounding borons, and the formal negative charge is on boron atom. So that's why they are very big and non-nucleophilic. That is the advantage, remember. And presence of 4 bulky phenyl group, that is organic molecule, helps the salt to solubilize in the organic solvent. Like you say phase transfer catalyst, R4 N plus X minus. These are, since these R4 are organic and bigger, that's why all these salts are soluble, although cationic species doesn't soluble. So that uniqueness of this alkyl group makes this salt soluble in both organic medium as well as inorganic medium. That's why they can act as phase transfer catalyst. And the last thing, the insoluble salt byproduct, that is sodium chloride or silver chloride, helps to produce the reaction forward direction, since they are precipitate out, so equilibrium force to go towards the forward side. Okay, and this discussion is you can visit this in reference for better understanding. Now this is the end of the discussion. If you really like my teaching, please like, comment, share and subscribe my channel. And thanks for watching. Stay happy, stay blessed. See you in my next video.